So let's talk about intersecting of two objects. I'm going to do this in 3 steps with 3 different programs. So the first one is just going to show the distance between two objects, and then we're going to build on it from there so we can get some intersection. These 3 tutorials do not use any classes. It's all just done with between two objects in setup and draw. So I've got a couple of variables up here. The first two are gx and gy, and these are the starting locations, or in fact, in this case, the only locations of what I'm calling the good guy. So he's going to be at the bottom of the screen, the middle at the bottom. Then I've got 2 variables for what I'm calling a coin. So the good guy's going to catch the coin, and this object is going to start at the top of the screen in the middle at 10 pixels down. And then I've made another variable that I'm not going to give an initial value to. This is d, and this is going to be the distance between the coins. And this program is going to check continually every time draw loops through to see how far apart these 2 coins are. I remembered to use my size this time. Great. So these 2 functions, this fill and ellipse, make my good guy. He's at gx, gy, so that's again at the bottom of the screen. He's at 250 and then 490, and he's 20 by 20, and he's red. At the top of the screen, you'll see this a teal ellipse, and I'm calling a coin. He's located at cx, cy, and also 20 by 20. And this equation will move him down. Every time draw loops through, it'll add 3 on to the y value of the coin, so he'll move down the screen. Now, this function, the distance function, right here, is going to check the linear distance between these 2 points. The parameters, the first 2 parameters are 1 point, gx, gy, so the xy location, in this case of my good guy, the center of my good guy, his center, and this is going to be the x and y of the coin. So the distance function will calculate the linear distance between that. So I'm setting that distance to d, so every time draw loops through, the variable d gets reassigned to the distance between this point and this point. And so I'm going to print it out, so we're going to see it here. So first it's going to get smaller because the coin has become closer to the good guy, but because there's nothing stopping him, he's going to pass right through, pass down past the bottom of the screen. We're not going to see him anymore, but their distance will then start increasing. So since I'm using print line, it's going to print down here in the console. So there, as you can see, it's getting smaller, 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 and then it's getting bigger now that he is continuing to move off screen. So that's how you use the distance function to check the distance between 2 points. And again, that's the center of the good guy and the center of the coin. Okay, so for step 2 of this video, I stopped that, yeah. Okay, everything is pretty much the same, except here I'm checking to see if the distance between the 2 objects becomes less than 20. And not the distance between the 2 objects. If the variable d, I jumped ahead of myself, if the variable d becomes less than 20, it's going to print out the word caught here instead of printing out the distance the whole time. And again, d is the distance between the point gx, gy, and the point cx, cy. So those are the centers of the 2 objects, the good guy object and the coin object. So the reason I'm checking to see if the distance becomes less than 20 is because each of these objects has a radius of 10. They're both 20 by 20. They're both 20. They both have diameters of 20. So they have radii of 10. And so we're checking to see if the sum of their radii gets to be less, if the distance between them gets to be less than the sum of their radii. Again, if the distance between the centers of the objects is less than the sum of their radii, you know that they are intersecting. They are overlapping in some way. So let me show you a fun picture with some graph paper. Let's see here. So, all right, it's my rudimentary processing layout graph paper. I've got my good guy down here. I've got my coin here. And So this distance is 10. The radius is 10 from the center of the coin to the edge. And this distance is 10 from the center of the good guy to his edge. So the sum of the radii is 20. So if the distance between those 2 points is less than 20, you know they must be overlapping. So that's step 2. So here he comes, they get closer and closer, and then they're overlapping until, again, that coin moves farther down the screen. So finally, last step. We've got everything we had before. We've got good guy variables, coin variables. The coin is moving down. I've got now some controls for that good guy, the key controls, and that I went over that in another video. So now, if the distance between, I guess I didn't use my variable d here for some reason. All right, if the distance between the points becomes less than 20, let me change this just because it doesn't look like, I'm going to say d equals distance, and if distance becomes less than 20, then I'm going to move the coin object off the screen. I'm just going to send him over off screen so we can't see him anymore. So it'll look as though he has been caught and it's disappeared. Semicolon. Unexpected token if. Got to if, didn't know what to do. It's because I did not include a semicolon. I guess I didn't have a d variable here at all. That is very odd. I'm not starting this video over because it's been too long. I'm just adding it back in. So there, here I go. If I get him, he disappears. So again, I want to see, oops, if I catch him, he disappears.